Hello, this is our third video looking at normal curves. In these videos, we have been looking at normal distributions with a certain mean and standard deviation, and then transforming them into standard normal curves with a mean of 0 and a standard deviation of 1. When we do this, we are able to use the standard normal table to find percents to the left of particular values. These values are called the z-scores. In the last two videos, we looked at finding percents to the left and percents to the right. In this video, we're going to look at how to find the percent of data that is in between two values. Again, we're looking at this 1973 study done by the CDC, which found that 12-year-old boys had a mean height of 151.1 centimeters and a standard deviation of 8.18 centimeters. The question we want to answer here is what percent of boys in 1973 were between 140 centimeters tall and 156 centimeters tall. The first thing we're going to do is standardize both values. If you recall from our previous videos, standardizing means finding the z-score, and the z-score is given by x minus mu over sigma, where mu is the mean of the data set and sigma is the standard deviation. If I want to look at the first data value, 140 centimeters, the z-score would be 140 minus 151.1, all divided by 8.18. This gives us a z-score of negative 1.36. Now remember, the standard normal table only uses up to 2 decimal places, so we will round all of our z-scores to 2 decimal places. This z-score of negative 1.36 is about right here. Now we will repeat this on the second z-score. I'm going to give that a little sub 2. That's going to be 156 minus 151.1, again divided by 8.18. This z-score is 0.60. So this z-score is about right here. The percent of data that we want is the percent that lies between these two values. So on the curve, it's the percent that's in this area. So how do we find the percent in between? Here I have two standard normal distributions with our two z-scores labeled, negative 1.36 and 0.60. If I were to look 0.60 up in the standard normal table, it would give me all of the area from this point to the left, so all of this. If I were to look up negative 1.36 in the standard normal table, it would give me all of this area. To find the area that I want, which is the area in between, I can take this entire area to the left of 0.60 and subtract the area to the left of negative 1.36. When I take this red area minus this littler red area, I am left with just this purple area, which is the area between the two curves. So that's what we're going to do. We will start by looking at z1, which was the negative 1.36 in the standard normal table. Here's negative 1.3, 0, 1, 2, 3, 4, 5, 6. This one is the percent of data that is to the left of the z-score, negative 1.36. The area to the left of z equals negative 1.36 is 0.08691. Now we can repeat that with our second z-score, which was the 0.60, and the area that we find in that case here's 0.6, 0.60 gives us an area of 0.72575. To find the area in between, we are going to subtract these. 0.72575 minus 0.08691 gives us 0.63884. That is the area between z equals negative 1.36 and z equals 0.60. We can convert that into decimal form. That would be 63.884%, which means 63.884% of 12-year-olds would be between 140 centimeters and 156 centimeters tall. So if you want to find the area between two data points, standardize each data point. So you get your two data values. Subtract the areas to the left of the two z-scores. The larger area minus the smaller area. That gives you the area in between the two z-scores. And then convert that into percent form.